670. So now we are going to start a new module. We're officially done with test prep. So I'm going to walk you through everything that you're going to need to do for this lesson. The first thing you want to do is when you get to this lesson is you want to watch this video called I Forgot My Phone. The next thing you're going to do is you're going to open the document titled Module 4A Gallery Walk, which is right here, and that's going to lead you to a document that's going to look like this. Now, on this document, you're going to have 4 quotes and 3 images. Image 1, image 2, and here's image 3. I'm just going to explain what this graph is. The name of it is Average Hours Spent Per Day in Leisure and Sports Activities by Youngest and Oldest Population. So by leisure, we mean things that you do for fun in your free time. So on this part of the graph, you have the average hours per day, starting from 0, then 1, then 2, then 3, then 4, then 5. And on this side of the graph, you have various different activities. The first one is watching TV, the second one is reading, then there's relaxing and thinking, then here we have socializing and communicating, then we have playing games or computer use for leisure, and then we have sports, exercise, and recreation. Now, as far as what the blue and the green represents, the blue represents people ages 15 to 19, and then the green represents people who are 75 years of age or older. So with that in mind, I want you to just observe this graph and see if you can spot any patterns in terms of what people do in those different age brackets. So after you read all these quotes and you observe and examine these images, what you want to do is make a prediction based on what you saw in that document. Make a prediction on what you think we'll be studying throughout this module. And you're going to go to assessments and click on the assessment title 420 ELA classwork. And over there, you're going to write your prediction. Now, for the exit ticket, that is going to be based on an article called Teens and Decision Making. So the text for this article is right here. And if you're watching this video, you'll see that I'm going to go through the article with you. All right. And the exit ticket for this article asks us, according to the article, how is the teenage brain not fully developed? How does this affect the behavior of teenagers? So we're going to pay particular attention to that as we read this article. So let's start from right here. Teens and decision making, what brain science reveals. Do you ever act before thinking? Have you ever wondered why? Do you worry this might create problems? If you answered yes to any of these questions, read on. Picture this. Your finger is poised on the send button, your eyes scanning an angry email you've dashed off to a friend who has upset you. Some things you've written are a little harsh. In your brain, a little red light goes off. But what the heck? You're steamed and your friend deserves it. You push the button. Whether you're aware or not, rush decisions like this, acting before thinking it through, happens more often in teens than in adults. Recent discoveries in brain science may help explain why this is so. First, a bit on how a brain makes decisions. Decisions don't just happen automatically in your conscious mind. They stem from a series of events in the brain, which happen almost instantaneously. This involves a relay system in which different structures made up of specialized cells, called neurons, talk with each other by way of electrochemical impulses and chemical messengers called neurotransmitters. So there are 2 key terms we just came across. One is called neurons, right? And what are neurons? They are those specialized cells that we were talking about, right? And what are neurotransmitters? neurotransmitters, those are chemical messengers. All right. Information, excuse me, information flowing through this decision-making circuit is analyzed into different structures. Then the network as a whole puts out a response. This output provides the basis for our behaviors and actions. While this process is basically the same for teens and adults, the devil is in the details. Since the brain is not fully developed until the early 20s, the way in which a teen's decision-making circuit integrates information may put him or her at a higher risk of making decisions the teen could later regret. So far, this article has basically set the tone by telling us that the teenage brain has not fully developed, and therefore, because of that, teens don't always make the right decisions. Now, it hasn't really explained in detail how the teenage brain is not fully developed. All right, so it's just a brief introduction, so we haven't gotten to the details yet. So far what we have read won't exactly help us answer the question yet. But let's continue reading. The teen brain under construction. Not long ago, scientists thought the human brain was fully mature long before the teenage years. While research shows that one's brain reaches its maximum size between ages 12 and 14, depending on whether you are a girl or a boy, it also shows that brain development is far from complete. Regions of the brain continue to mature all the way through a person's early 20s. A key brain region that matures late is the prefrontal cortex, located directly behind your forehead. The prefrontal cortex is very important as a control center for thinking ahead and sizing up risks and rewards. This area is, in fact, the little red light that was trying to warn you about sending that email. Meanwhile, another part of the brain that matures earlier is the limbic system, which plays a central role in emotional responses. So, we have seen in this section so far that this is what develops late, right? So we see that for teenagers, the prefrontal cortex has not fully developed, right? And that is responsible for decision making, thinking ahead, calculating risks, and trying to decide if something is the right thing to do or not. As we saw in that example in the first paragraph about sending that harsh email, right? And because the prefrontal cortex is not fully developed in teenage brains, that could help explain why teenagers make decisions quickly without thinking. Since the limbic system, right, which plays a central role in emotional responses, since the limbic system matures earlier, it is more likely to gain an upper hand in decision making. This relationship between the emotional center, the limbic system, and control center, the prefrontal cortex, helps to explain a teen's inclination to rush decisions. So when you think of why a teenager might rush decisions without thinking them through, it's because the limbic system is taking over more, which is driven by emotional decision making, emotional responses. So it might cause you to do something because you feel a particular way and not because you have thought it through completely. In other words, when teens make choices in emotionally charged situations, those choices are often more weighted in feelings, the mature limbic systems, over logic, the not yet mature prefrontal cortex. So what they're saying is that teenagers make decisions based mostly on how they feel and not by thinking and using logic. This is also why teens are more likely to make bad choices, such as using drugs, alcohol, and tobacco, all of which pose a risk of serious health consequences. Most kids don't really plan to use drugs, says Professor Lawrence Steinberg of Temple University. At least not the first time. They are more likely to experiment on the spur of the moment, particularly when influenced by others, peer pressure. Now, if we look back at the exit ticket, we now have somewhat of a better idea on how the teenage brain is not fully developed, because this entire section that we read pretty much discussed that, and as well as how it affects the behavior of teenagers. So if you're looking to answer that exit ticket question, you should pay particular attention to this section that we just read, the teen brain under construction. Let's continue. Fine-tuning the brain. Like the rest of the body, the brain needs to mature in order to reach peak performance. This process involves slow changes strongly influenced by brain activity that have evolved to fine-tune or optimize how neural impulses flow throughout the brain, allowing it to process information faster and more reliably. Inside the brain, information travels through a network of neurons, which have thread-like fibers called axons and branch-like structures called dendrites. So you can see that right here in this image over here. The dendrites are pointing to these right here, and here are the axon terminals right here. Dendrites bring information into the neurons, while axons take it away and pass it along to the next neuron. Thus, neurons are assembled into circuits where the far end of an axon is positioned close to a dendrite. The small space between the two is called a synapse, where information is exchanged. So once again, we can refer to this image, and this small little bit of space right here, very, very small, is the synapse where information is exchanged. Throughout childhood and adolescence, the brain is busy fine-tuning itself through two key processes, myelination and synaptic pruning. In myelination, axons wrap themselves in a fatty substance, a myelin sheath, which works like the insulating plastic that surrounds electrical wires. Now let's look at where the myelin sheath is on the image. Right, this is the axon right here, and it is wrapped in the myelin sheath, which is right here. Right, so you can kind of think of the electrical wires being wrapped in the cords. Let's read that again. In myelination, axons wrap themselves in a fatty substance, the myelin sheath, which works like the insulating plastic that surrounds electrical wires. This boosts the brain's efficiency by increasing the speed with which a signal travels down the axon by up to 100 times. In synaptic pruning, synapses not used very often are removed, allowing the brain to redirect precious resources towards more active synapses. This strategic loss of weak synapses shapes the brain and makes it more efficient. This important pruning process molds the brain in response to a person's experiences and activities. This means that teens have the potential, through their choices and their behaviors they engage in, to shape their own brain development, strengthening some circuits and getting rid of others. This makes the type of activities teens are involved in especially important. Skill-building activities such as many physical, learning, and creative endeavors not only provide stimulating challenges but can simultaneously build strong brain pathways. When teens learn and repeat appropriate behaviors, they are helping to shape their brains and their futures. Wait a minute. Learning how your brain works can help explain why sometimes you behave like you do. With this knowledge, you can be better equipped to make smart choices. One tip to follow is to take a moment before acting. When making a decision, something as simple as stopping to think can mean the difference between a positive and a negative outcome. By waiting a minute before acting, you allow yourself to consider the consequences, weigh harmful outcomes, for example, harm to yourself or others, against short-term benefits, example, fitting in with your peers or feeling high. Determine whether peer pressure is making you do something you'd otherwise not do, and get information or advice if you need it. All right, so with the knowledge that you've gained from this article, you should be equipped to answer this exit ticket question. Now, I didn't say that you had to use evidence from the text. That is optional, but what I do need you to do is to write a detailed response that clearly uses what you have learned from this text. All right, and that is all for this video.